Okay. Good afternoon, everyone. On behalf of agricultureinformation.com, I'd like to invite the speaker, Mr. Dinesh Kar, who will talk about leveraging geospatial technology and revolutionizing agriculture. I now request the speaker to begin. Thank you.
Thank you. Thank you so much for the introduction. Before starting the presentation, let me just give a brief introduction about myself. I am Dinesh Kar. I'm basically a geospatial agriculture strategist, a consultant, an advisor, as well as an author of a couple of books. I'm also a co-founder of a company by name Crop Intellix Private Limited. Today, I'll take this session about how we can leverage geospatial technology uh, in agriculture sciences. So to begin with, I will be sharing with you some of the slides. So my slides will have why geospatial technology in agriculture, then what are the types and levels of geospatial agriculture information in agriculture. I'll also touch based on some of the case studies which I have taken up in my during my past companies. Then who are the agricultural stakeholders that are using and taking the benefit of this technology? And what are the different services and solutions which are helping in agriculture? So to begin with, why are we talking about geospatial agriculture? Or why are we talking about digital agriculture? Geospatial agriculture is it's a technology, it's a part of a digital agriculture. So as we know that we have been going through some of the revolutions in agriculture, that we were like a tribes and we became a settled agriculture in our first resolution. That was we started growing our food in one place. Then slowly there was another resolution, a revolution where we started using implements. We started knowing about how the crop has to be rotated based on the season. We also learned about the conversion of land from the grassland or the pasture lands into the agricultural land. So there were some of the learnings during that revolution. Then there was a third agriculture revolution, which we are all part of it. This was when the high yielding varieties were introduced. The chemical fertilizers were introduced because when you are having an high yielding varieties, definitely the crop will demand for more chemicals into that. So chemical fertilizers were introduced. The crop package of practices were designed, and it was designed in such a way because how a variety will perform when it has to be sown, and how many days after the interval of how many days the application of fertilizer has to be done, when it has to be done for the it has to go for agriculture operations, and then the harvesting cycle. So everything was completely packaged, and now still we follow those things. Currently, we are into the fourth agriculture revolution where uh, it is a kind of a like it's a marriage between the data and technology to do the agriculture. So here, why this is happening is because there were always a need, there was a demand. Like in first revolution, it was something like the farmer wanted to become the self-sustained and he wanted to grow his own food rather than hunting and gathering. Wanted to grow the food. There was a demand for that. Second, it was when there was a to increase the productivity. Third, it was again when the population was increasing, the we were having a lot of available land, and so there was a demand was there. Now again, there are multiple demands are there. Population is increasing, soil is degrading, your competition is increasing, the product value is changing, markets are demanding in a different way, consumers are demanding in a different way, the eating habits of consumers are changing. So digital technology is now coming up with that. So this is what is the glimpse of that. Like in the second revolution, One farmer was supposed to feed the 26 people. Then third revolution, it was around one farmer was feeding around 155 people. Now there is a demand that one farmer has to feed around 260 people. So this is where the technology has to come. Now many people will be having a question that can technology grow the crop? No, but technology may not be directly putting the seed on the ground or doing anything to the seed that so that it can grow. But no, technology can help you in taking the proper decision when to grow, how to grow, what to grow. Technology can help the agri businesses to help the farmers in giving the advices. Technology can help in properly designing their farm. Technology can help in properly marketing the product. Technology can also help in uh, providing the better prices and other benefits to the farmer. So this is how technology can be. If it is not, then we will remain the same as we were doing it 30 years back or 50 years back. That's why the use of technology is very much essential. So the technology megatrends that are happening now are the big data, digitalization, Internet of Things, AI, ML, and blockchain. If I'll be talking about this geospatial technology. Big data is part of that. We in geospatial technology, whatever the data has been used, that's the big data. The conversion of big data into the output, that is the digitalization. The speed and the process, that is the way it has been used to generate the output, is again AI and ML in that. So blockchain and Internet of Things will be slightly different in that, but yes, they can also be used in this geospatial technology. So what are the applications that have been currently used? Some of the uh, topics that I can highlight upon is like crop management. Uh, if a farmer wants to monitor the crop, see, usually what he does is he will go with the normal package of practices. Okay, by the onset of monsoon, he has to sow the seed. Then he has to provide some irrigation. Then he has to provide some fertilizer, then chemicals, and he keep on doing that till the crop gets mature. So in this way, what actually is happening is uh, the application of fertilizer is as per the package of practices, not as per the need of the crop or not as per the need of the soil. Then if digital technology is there, technology can tell you what is the exact need of the soil, what is the exact need of the crop, and then the fertilizer dose can be designed in such a way and then applied. This way, farmer can reduce the input and increase the productivity. So by reducing the input, you are gaining some financial benefit. By increasing the output by the quantity as well as the quality, again you are getting some benefit as a price. Then automatic irrigation system. Irrigation, again, mostly we have seen that because of this free electricity and water, we are continuously flooding the field, by which the uh, the actual need of the crop is not calculated. We call it as crop water requirement. So if it is automated, then you can save water, you can save your labor in that, and again you can save the uh, price in that. Livestock management, like the health of the livestock can be managed by putting the sensor in livestock. The quality of milk, the when they're in the grazing land, the counting of livestock, the movement of livestock can be tracked. In the indoor vertical farming or the smart greenhouses, here the non-seasonal crop can be grown during any season by controlling the climate and environment inside the greenhouse or a poly house. So this is a smart technology, and farmer can get a good price. Just like you can see that nowadays we get apple 12 months. Then oranges also we are getting 12 months throughout the year. Papaya we are getting, jackfruit we are getting throughout the season. Watermelon, musk melons are still available during the winter season in Hyderabad. So this is because of the indoor farming, the controlled environment. We call it as controlled agriculture. Drone farming is where you can in drone we have two things. One is by drone you can do the drone surveillance or you can do the drone based spraying. So these are some of the things you can do: the farm automation, robotics to control the labor, farm management, uh, like each and individual farm can be managed, the soil quality, the water quality, the labor requirement, the input requirement, the product storage facility, everything will come under the farm management. Produce monitoring, supply monitoring, so how from the farm gate it goes up to the mandi or it goes up to the consumer level to the retailers or the wholesalers, the supply can be monitored. Coming to the geospatial technology. So geospatial technology is it is nothing but it's a combination of two major technology. One is a remote sensing and one is a GIS. So remote sensing is nothing but any object if we are sensing it without physically touching it. For example, just now, if you are looking at this video or if you are listening to me in this session, you are not in physical contact. We are not somewhere close to each other, but still you are able to see me, hear me, and understand me. So you are remotely sensing me. The same technology is used here. In remote sensing, either there is an aircraft or the satellite, which is in a far distance from the ground level. It takes the picture of the ground and then provides a picture. So it has sensed and it has taken a picture. As a remote sensing expert, what we will do is we'll try to interpret those images and convert those pictures into data. Uh, to give you an example, suppose if you are taking a mobile phone and you take somebody's picture, then once you see the picture, how you are interpreting it, okay, the color of shirt is blue, the background is very nice, the trees are green, like that. So you are now converting that into data. So this is what is done in remote sensing. In geographic information system, we try to attach some attribute to it. If it's like any red color is there, what does that red color mean? Green color, what does it mean? Blue color, if it's a water body, then again in water body we can say whether it is a river or whether it is a pond, whether it is a lake. Then again we can say whether it is a deep water body or a shallow water body based on the color of the water. So this is geographic information system. Remote sensing is giving you a picture. Geographic information system, you are adding an attribute to it. Using GPS, you are giving a locational information. Like, where is that? If there is a water body, then where is it located? What is the latitude and longitude of that place? So, which place it is located? So, this is geospatial technology. We usually call that a geospatial 1.0. Now, there is a revolution in geospatial technology as well, whereby the use of artificial intelligence and machine learning, the the process is what we call it as there is an improvement in the speed and accuracy of decision making. So usually what used to happen earlier is from the satellite we used to take the picture, then the picture will come, you convert them into the digital numbers will be converted into pixels. The pixels will be interpreted. Then after interpretation, it will get it to a GIS system. Then in the GIS system, you will be having the attributization. Once the attributization is done, then you will be having a thematic layer preparation. So these were multiple steps. But now using machine learning, everything is being automated. You already have the trainings. algorithms built through which you have to just give the input. This is the satellite imagery with a special resolution, whatever it is, you mention it, and then the system does everything. So this is where is the geospatial technology 2.0. So there are multiple stages in geospatial technology. One is the data. Okay, if it is just a satellite imagery, or in agriculture, as we know that we get weather data, we get climatic data, we get soil data. So these are data. These are in numbers. These are in pictures. So this is just a data. If you put some context to it, then it becomes information. For example, if that same satellite image, I am converting it into a soil layer, crop layer, land use land cover layer, then it's an information. Okay. And again, if I use some rules into it to do some kind of a, let's say, crop intelligence information on where the crop is, what is the health of the crop, how the crop is behaving, uh, then soil, what type of soil it is there, whether it's a black soil, red soil, shallow soil, deep soil, kind of a thing. So this will help me in doing more uh, theme-based analysis. And if I'm having this data, information, and knowledge with me, I can get into the next level, which is providing the consulting and advisory to the users. So now this is how, using the data, information, and knowledge, we are generating the advisory system, how the crop advisories are built. So you might have come across some of the mobile apps or the digital dashboards where um, they are giving the advisories. Uh, in your area, the soil is like this. The temperature in the next 7 days will be XYZ. The rainy patterns will be like this. And based on the land use land cover pattern and the soil type, we advise you to do so and so A, B, C things. So how they have done it, because they have this data with them, they have the information with them, they have the knowledge with them, so they are providing the advice. So this becomes very easy, not every time going there and doing the study then and there itself and then providing the advisory, it will be time taking. The same thing can be automated. Now, when the data and information are together, we have seen a lot of websites like where the weather data is available, like IMD data. It's an information system. We have our crop-based information system where the area production data are available. We have census data, we have population data. So they are all information system where we are getting the data. That means some numbers are there. How you are interpreting it's up to you. Okay. But if there is the next level of system where data is there, information is there, and then you are able to make some decision, then it becomes decision support system. Like there are many uh, irrigation water management system where if you know what is the area of the crop present there, what is the soil type, what is the crop water requirement, what is the moisture content present now. So then you can take a decision. If you put all this information into that, automatically the system will tell you, okay, so much of irrigation can be provided. Or at present, the irrigation is not required. And the farmer can wait for another 5, 6 days. So this is how the decision can be taken. Then there is an expert system. Expert system in agriculture is like you provide a question and it gives you the answer. Just like we have a Google search engine or now ChatGPT. We are giving the question and it is giving us the answer. But what is happening behind that is the user puts a request, it gets into the user interface, then goes to the rule engine and it finds the similar kind of a answer from there and then comes back with a response and gives it. But what is happening in the background is There are a lot of expertise is going on there who are putting their expert and they're putting the answers to it for the similar kind of a question. So here, uh, just one example I can give you in this digital technology in agriculture is uh, farmers are using this mobile-based app where they just take the photograph of a diseased leaf and then upload it into the app. Then immediately they get the answer what kind of a disease it is and what protective measures they have to take, what they have to apply. Same is with even in our geospatial technologies, you put the satellite image and based on the reflective index of the crop, it will tell what type of crop it is, what is the health of the crop it is, and what is the moisture content of that. So based on the different vegetation indexes, we have NDVI, we have NDWI, we have enhanced vegetation index for the crop canopy. So multiple index can it does it, and then it gives the answer. That is the expert system. I'll come to the second part, which is the type of user they are using the geospatial technology. First is what kind of information is required. See, farming, right, it starts right from the land preparation till you sell your produce or till you go for the next crop. Every time some or the other information is required, whether it is related to weather, climate, soil, the crop performance, the yield, production, the market demand, everything, and at every stages. And it is required not only by the farmer, it is required by the agri businesses also. For example, if I can take an example of a trader wants to know, like, uh, this year how the crop sowing has happened. If he is a trader of a paddy, then he wants to know how much of the area is grown, where it is grown. Then he also wants to know what is the health of the crop. Because if the health is going down, he will book less. If the crop is performing well, he will book the produce more in that. Then if yield and production estimation, if it can be estimated well before the harvest, how much the produce will come. So then they can plan their procurement. Also the harvest monitoring, from which place, how much, the uh, how the product means how the harvesting is happening, where it has started, where it is still yet to be started, where it has come to the mature. So which mandi where the product will come. So they can do their planning. So this is how every businesses, insurance people need their different kind of a business where the crop is grown, how much the crop is grown, what kind of event has happened, how much the damage has happened, what is the intensity of damage, what is the extent of damage. So this can be done. So geospatial technology can solve all these problems, whether it's a crop forecasting related information like crop acreage, crop yield prediction, health monitoring, mapping and monitoring of plantations, differentiating between crop and plantations. Similarly, for sustainable agriculture, you can do the land evaluation and suitability, soil resource mapping, livelihood improvement. For each livelihood, whether it's a bamboo-based livelihood, whether it is a banana-based livelihood, whether it's a farming-based livelihood. So each livelihood-based data and information can be generated. The impact assessment, the disease impact, the damage assessment, and developmental projects like planning, your perspective land use planning, watershed development, waste management, all these things can be done because geospatial services, as I was telling that, it takes the satellite imagery. So if you want to do a single farm level analysis or a management, it can be done. And even if you want to do a village level, taluka level, mandal level, district level, state level, or even at a country level, the satellite imageries can perform. So a different satellite resolution image has to be selected and then you have to perform the analysis. So that is the beauty and advantage of remote sensing and GIS. So you can do a single plot level analysis to even up to country level analysis. So what kind of different analysis can be done? One is we call this a descriptive analysis. Okay, so this is like You have taken a satellite imagery and somebody wants to know what has happened, like how much is the crop. So crop is already sown and you are giving an information. That's a descriptive analysis. Somebody says that, okay, damage has happened. How much the damage is? So damage has happened. You took the picture, you analyzed it, and you have given it, okay, so much of damages. So that's a descriptive analysis. Second is diagnostic analysis, why it has happened. So here you can do a different type of analysis by the vegetative index, or even sometimes you do a temporal analysis by taking multiple sets of images, why it has happened. If any damage has happened, then why it has happened. The third type of analysis that can be done is the predictive analysis, like yield prediction. When the crop is still standing, it is in the vegetative stage, you can do an analysis and tell how much of the yield will be a farmer can obtain. Second is disease and pest prediction that can also be done. So predictive analysis is also one part of it. Then there is a prescriptive analysis. Like you have done the descriptive, you have done the diagnosis, and you have predicted. Now you can prescribe it what is to be done. So if there is, you are predicting any kind of a damage which is going to come, then you can prescribe what are the protective measures. Or if you are predicting the yield, how it can be taken to the market or storage. So those kind of a prescription can be done using this technology. Now slowly I will get into some of the case studies. So we'll start with this. As I was telling that remote sensing can be used in mm, from a plot level analysis even up to um, country level analysis. Okay, precision farming, as we know that it's a site specific crop management. I'll touch base one of the case study. So this was done in Nicaragua. So if you look at the slide, here I've got two pictures. The top picture, right hand side picture, that was the only information provided by the client. He wanted to know that he is having a banana plantation and he has just given what is the plant to plant distance and row to row distance and wants to know the tree counting and how the banana crop is performing. So what we did was we have done all our modeling into that. We took the satellite imagery, very high resolution satellite imagery. And then based on our model, we have done this analysis where it automatically detected the length of the line. So based on the length of the line, now we can say we can calculate the plant to plant distance, to row distance, and then tell the population. And also we have given them the information about where there is a gap, where there is a like there is no crop in that. So that was one information. Second information is the performance. So now you can see here there is a what we have done is we have done the vegetative index analysis. That is the normalized differential vegetative index NDVI. So if we have run the NDVI through NDVI, now we can see that in the four blocks, the left hand side two blocks looks very light in color, right appears dark in color, which means that the right hand side is performing well, left is not performing well. So to check it, what the next step we have done is we said that okay, let's see whether the farm manager or the laborers they are properly giving the water or not, properly irrigating or not. So we did the water index. Now through water index, what we have found that we could not find any much change. So that means the irrigation is given properly, the farm management is being done properly. So might be there is some either the varietal difference or the growth problem or there is a soil problem because of which these left hand side of the blocks are performing poorly than the right hand side of it. So this is how the information can be given and now the owner of the land can focus on the left hand side of the plot and do a protective measure there. How crop insurance are using this technology? They want to know. Okay, to start with, for example, now let's say there is some flood has happened, some um, sudden downpour has happened in one of the talukas. And then the news spreads that, okay, the insurance companies will be giving the benefits to the farmers. So what usually happens is every farmer will go and tell them that my crop is damaged and I need a benefit. Okay, but instead of giving 100% benefits, now the insurance company will also lose all the money. So what they are doing is they are doing this study that they want to first understand what is the extent of damage, whether the entire taluka has got damaged or there is some level uh, where severity is there or where less is there like that. How much of the extent? Then intensity. That's the severity. Whether it is severe 100% loss or 60% loss or 20% loss. Then how much of the crop grown is damaged? Because there will be many wastelands or there will be non-crop, non-insured crop will be there. If people are coming for paddy insurance, but if they have grown, let's say, maize or they have grown some other crop, so they won't get. If they have opted for paddy insurance, they will get the paddy insurance. So satellite can detect all these things. Then what stage of the crop? So if it's at the sowing stage, what kind of benefit they can get? If it's a vegetative stage, what benefit they can get? If it's at the harvesting stage, what benefit they can get? So this is how they do it. Extent of damage, intensity of damage, the crop growth. So how they do is they take the mobile application, do the boundary, because if farmer is telling that I have got a 5 acre of land, but if he has sown only 2 acres of paddy, so only 2 acre will be counted, not the entire 5 acre, which he owns. Then all the data will be fed into it. This data will then come into the dashboard, and then using those points, we will take a satellite imagery. This is satellite imagery, and then we will perform the crop mapping. What type of crops were there? Then we do the temporal analysis, that is the before event analysis and after event analysis. What has happened? And then different index analysis. You can see on the left hand side there are multiple indices: NDVI, SAVI, GCI is chlorophyll index, red H chlorophyll index, structural intensive pigmentation index. So different index will give a different kind of a information about the damage. Then you compare with the before event and the after event. And finally, you do the analysis by integrating all the indices and generate a report. So here we can see like different farmers are having different kind of loss. Some are having 20% loss, some are having 40% loss, 30% loss, 80%. Now, based on this loss, now the the insurance amount will be calculated. So each farmer will get the benefit as per the loss they got. This is another example from the drone. See, drone is very much helpful if you are doing a small scale study like 10 acres, 5 acres, 40 acres, 50 acres, like that. But not at a regional level, study a village level, taluka level, district level. It becomes very costly. Okay. And the advantage is you can monitor it. So this is one of the drone image taken. Uh, so we have made it into a false color composite because the drone has got the camera which has also got an NIR band, near infrared band. So whatever is appearing green on the ground will appear red on the image. So this is a vegetable garden. The image, a false color image from the drone. When the analysis is done into it, this is how it will come. So all the dark green and green color are the healthy one, even up to blue and yellow. Till yellow, it is the normal. The moment it goes into orange, pink, or red, these are having some problems. So now farmer can take a decision where they have to do and what they have to do and how much. So he need not have to apply the fertilizer or chemical in the entire plot in every blocks. No. Only wherever there is a damage, wherever there is this orange, pink, and red, he can apply. This is another plot again taken from the drone, and this is how we can do the analysis and perform the farm management. So wherever there is uh, damage area, only in those damaged area, the protective measures can be. This is another place, and now here only the top blocks appears to be having some red and orange place, so there only you can do whatever the care can be taken. This is one more example where without means going to the field, this was actually for a client who wanted to buy a land, um, and before buying, he wanted to know what is the area of the land because he was told that it is some 10 acres or 10 hectares kind of a thing. So he wanted to measure without actually visiting and then also to study the slope of the land so that he can put the storage tank and then do the farming there. So he did this analysis without visiting, just by taking the satellite imagery. Yes, it was 10 acres of the land. And then by taking the elevation into consideration, the contours were generated. And through the contours, then we came to know that, okay, the slope direction is from north to south. And the sites were identified where they can put a water storage tank so that this water can be stored and then it can be used in the non-rainy season. So this is how the service can be provided to any client without actually visiting the field. That's the advantage of remote sensing. This is one more case study, which is for us for a region where it's for a sugar mill. So they, as you know, that mill will be having a reserved area. So this is the one case where we met this client in one of the conference, and we came to know that they are starting a sugar mill, and they have already started the construction of sugar mill. And what they were doing was, this is what they provided. These were the photographs that they have started cutting the trees. They are using heavy implements, putting the land under fire. So we told that these are all unplanned way. This is not the way it has to be done. And we asked them that we will do a remote sensing based study. We'll give you a proper plan that will be beneficial. The second question we asked was, other than this, what they have done? They said that they have already started the construction of mill, and mill is going to complete in another 2 3 months, and then they will do the processing. So we asked if it's a sugar mill, whether the sugar cane you have studied it or not, whether it is available or not. They said no, we are now creating the land for it, and then we will grow. So we told that this is not the way because if you sugarcane is not a 2 months, 3 months crop. It's a 12 months to 18 months crop. So you have to first plan your raw material and then do the mill planning. So we asked them to stop the mill construction work for a few months and focus here and then first focus on the growing the crop. So what we did was we took a satellite imagery. This is the pre-monsoon. Whatever the black now you are seeing is the area they have burned it. And red, as I told, whatever green on the ground will appear red. So this is the pre-monsoon time, post-monsoon time. So this is the place where they are constructing the mill. Okay. And all these are forest and scrub areas, no sugarcane. So we said that, okay, we'll do the planning for you. So we took this pre-monsoon image, post-monsoon image, digital elevation model to also get the elevation and height. We prepared the land cover map, slope map, physiography map, like from the hill up to the valley region, how the physiography, that's the landscape or the landforms. Then we did a land suitability zonation, like which lands are actually suitable for sugarcane and which are not suitable for sugarcane. If you grow sugarcane there and if it is not coming, then again it's a waste of your resources. So we created this. So all the red and light green color were removed from that place. Now there is another thing because in Africa, when they have taken this land, all these lands are taken on lease. They have to pay the lease amount for each and every piece. So now the owner started telling us then what they will do for this red and light green patch. If whether they use or no, if they don't use, they have to pay the lease amount. So we said that okay, we'll plan for that also. We did the plotting that how your plots will be, and then this is how your each and every sugarcane plot will be there. Now, what is to be done for the red and light green patch where it is not there? Oh, other than this, we also did the water harvesting structures where how they can control the irrigation, where they can store it, and how they can distribute, how they can irrigate their plant. And then the final, the plan map was prepared, the sugarcane areas. Then the non-sugarcane areas, we suggested them to go for clove and nutmeg. Then some avenue tree plantations were also suggested. Some recreational facilities were nearby the farming areas. Proposed a site for schools and health facilities. They were also designed in this. So this is how it was done. So to do this, we also conducted some of the field level studies. So that's actually me. I'm there in the soil pit studying the soil, and we did the soil mapping and suitability zonation by all these things. Now I will take you to one of the very interesting study if you want to go for a smart irrigation system, how it can be done. So now you can focus on this satellite image as well as the date that is written on the top. And as I told, the red is the crop, which is green on the ground. And whatever is the other colors, the light colors are the dry fields, and then the slowly the moisture is increasing based on the color and tone. The dark patches, this means this is having more moisture, this is having little less moisture, and these light patches are less. So now this is the month of June, then 11th June, see the darkness is increasing. Now here also you can see 21st June, again the dark color has increased and now red is also increasing. That means the sowing slowly is starting. Sowing progress has happened. Here you see the more all the lands have been prepared and the sowing has improved. Both sides of the canal. In between, this is the canal. Now the sowing has further increased. This is in July. Now August, almost complete. Now it is completely done. All lands are covered. Now this is the we call it a temporal analysis of satellite imagery. This is the satellite view. Now if I put my index into it, this is the moisture index. So my moisture index will tell me which fields are having more moisture or water content and which are having less. The same sets of images. Now I am doing the moisture analysis. Now you can see how the dark color is increasing. So that means this is how the moisture has increased from light blue and now this. Now the question will come is, suppose if I want to give any advice to anywhere, any farmer, how will I know which plot, what is the size of the plot? So what we can do is, there is another case study I'll show you. You take satellite imagery and then you overlay a farm boundary or a village map into it. And then do the similar kind of a study. So multiple sets of satellite imagery. Okay. And then you do a now moisture stress analysis or water stress analysis into it. Now you know here each and every farm plot how they are behaving. Okay. So now here all the blue patches are good patches, yellow yet to perform it. This is the months of May, June, July. So now here July. Now like most of the farmers in this village have already done something. They are in blue, but some are still in yellow. So these people we can approach and give them the advice. Remember, they have taken the advice and still, so they are doing. But still, there are some yellow orange patches. That means there is some performance, bad performance is happening in their field. So these farmers can be given an advice of like your crop is not performing well. You can do some kind of a protective measure. So now slowly they are getting into harvesting, and again the crop is changing from dark blue to light November month. The health can also be performed. Now this is for the health. That was for the moisture. Now this is for the crop health. See, green is a good one and red is the bad one. So all the orange and red, see lot of orange and red. May this is good in the month of July, September almost good. So only these people they are having some problem. October, then November. Now it has come to harvesting. So this is out. So now we have seen one was the plot level study, the banana case study, then or the land 10-acre land. We have seen a small area study that was the Uganda case study for a that was around some 28,000 hectares. Then we have seen irrigation planning. Now, if you wanted district level planning, if that has to be done, so this is one of the this is the last case study that we will now look into it. So, district level satellite imagery is taken. Okay, the mapping was done for groundnut and cotton, and then individually taluka wise the cotton acreage or the crop acreage was um, estimated, and then different performance. Now this is the crop condition. Crop condition that healthy and very healthy. So here we can see that about 2,43,000 hectares are there, or 2,76,000 hectares of cotton is there, out of which this many are healthy and very healthy. So if I have to send my any agriculture officer or anybody, I don't have to ask him to go and roam around all the entire district. That will be waste of time, resource, money, energy. I'll say that you focus on this only 912 hectares, which is under stress, and give them the advice. Now, where can they be found? So we can do this analysis. Okay, if it is in this talukas, then it will be. Or we can put a village boundary on that. Then individual villages can be identified where those 912 hectares are. So they can focus only the yellow patch and go there only. That is for the health. Now, this is the crop growth stage. We know that all the farmers will not be sowing at the same time. So, timely sown and the late sown. So, these are through the index, we can find out that around 26,541 hectares were late sown. The rest all were timely sown. Now, where are they? If it is taluka like this, but if it is village level, these are the villages where there were late sown. Similarly, the chlorophyll content means where farmer has given the proper fertilizers, is following the proper package of practice. So normal, high and very high we need not have to worry. We can worry only about the very low and low. So where are they? So again, we can find it out like this. So we can actually identify the the focused villages where there is a problem and then go and give the advisories there. Similarly, for crop canopy density, how the crop is behaving might be it is because of different varieties being used, or so how the crop growth. So again, that can be done. So we have done the health, then sowing, timely sown, late sown, chlorophyll content, and the growth. So then we can also do the monitoring. by taking a multiple images at the different times. Every 5 days, images are available. So we can do a monitoring every 5 days or 10 days, 15 days, 30 days like that. It can be done depending upon the requirement. So this is how we can say that, okay, June month is where all under soil. That's why it is like this. Peak crop season. Slowly the maturity has come in year October. It is getting into yellow. October again maturity, November, more into maturity, November, lot of crop is coming to maturity. Then we can generate the stats. And then village level maps can also be generated. So this is a stakeholder meeting because most of the time then you have to explain them about what is happening, how the map has to be read. So stakeholders have to be, they need to understand the how to read a map, how to read the statistics, and how to take a decision. So like this is we are the GIS team and they are the implementers. This is the Saudi team. In one of the project was done in Saudi Arabia for wheat and alfalfa. This is for rangeland again in Saudi Arabia. Uh, this is Mozambique. Okay, this is in Karnataka and this is in Uganda. The soil survey being done. So that's me. I'm standing here doing the soil survey. So I'm basically a MSc in soil science. So, and I use the remote sensing and GIS for all my experiments. So as I told about the stakeholders, yes. So input companies, they use it to know about where the crop is grown, how much the crop is grown, how the crop is performing. Manufacturing companies are using for the supply of their implements. Okay, so that if they know when the crop is coming at harvesting stage, so they can supply their harvester machine there. Commodity traders, they want to know the crop, where there is a crop grown, what is the performance, how much they can expect the production, when will be the arrival in the market, the age of the crop, like that. These things, mills, where is the raw material level, how much the raw material is available, how the crop is performing, when is the it is expected. Okay. So AI is helping us in data capturing, enhancing the data processing, reducing the human error, and giving us the real-time data analysis and insights. So the areas where these have been used: food supply, food wastage, food quality, pest and disease infestation, crop health assessment, soil fertility, crop insurance, crop damage, farm operations, and all these things. So this is all from my side, done with it. So thank you so much. I have also published some of the books related to it, which are the basics one, like sensing agriculture from space. The second book is about the 9 rules of geospatial consulting. And the third book is about the startup map. So if somebody wants to start a company in digital agriculture or anything, they can use this book. So this is all from my side. I'm done with it. If you have any questions or anything, you can write to me on this email. Yeah, thank you so much.
Okay. Thank you, Mr. Dinesh, for a detailed presentation. Since we are running short of time, actually, the time slot was for 30 minutes. We have crossed almost 1 hour.
Okay, okay.
So I'll see how many questions I can take quickly. So, one second. Okay. Um, there are few questions. I'll try to take them. So how can geospatial tools help farmers in crop planning and yield prediction?
Okay. So one of the crop planning, what they can do is, see, using geospatial technology, they can know about the soil health. They can know about the market demand, and based on the market demand. For example, a farmer is growing regularly paddy, but now he wants to earn more, and there is a demand for, let's say, corn. So using geospatial technology, first he can know whether his land is suitable for corn or not. If it is yes, then how he can do it. So this is one of the benefits that he can do. Then second is, yes, yield prediction can be done well in advance because using geospatial technology, when The crop is still at the vegetative stage. Using different indices, he can know how much the production he can get, what will be the yield, whether it will be good, bad, high, low, and then he can plan this one. So not only farmer, the big businesses can also use this technology, and they are using it. Any other question? Is there any other question? See, you are on mute, not able to hear you. So, what is the role of satellite data and GIS in monitoring crop health? Yeah, satellite data is it plays a very important role because satellite is the data you can obtain it every 5 days, you can obtain it every day also. So, if you want to do a daily monitoring, if you have a large farm, so every day you can run the index analysis and you can find out where exactly the problem is there, not the entire field. So you can run the indices like NDVI, NDWI, then SAVI, and then you can monitor the crop health. So this is how satellite imagery can help you in that. And it is very easy, simple. You don't have to go to the field. You have to just run the indices and it will tell you the location and the area. So based on the location area, you can calculate how much of the fertilizer will be required or how much of the pesticide will be required. And then you can uh, apply those things only at that
Okay.
patch. That is the site specific management.
Okay. So next question is, um, how can small farmers access and use geospatial technology at low cost?
Okay. So it is advisable that like it will be difficult for a small farmer to actually use it. Rather, they can take the service of geospatial technology because for them to get the satellite imagery, perform this analysis, and all this will be very difficult. Whereas there are some companies who are doing it and they can give them some kind of application in their mobile phone where they have to just draw their farm boundary. That's all. Then they can run their application and automatically they will get the advisory into that. Rest everything will be done by these experts who are there in the company. So they should not think about obtaining the satellite imagery or think about the performing any analysis. They have to look for the who is providing those services in that region. Then they can do it. But yes, if it is a big businesses, yes, they can do it. They can set up their small GS team into their company and they should do it.
Okay. And next question is, how does it help in water management and irrigation scheduling?
Okay. So water management irrigation scheduling is using the remote sensing, you can do the moisture, soil moisture assessment by the water index and the moisture index, NDWI and NDMI, and also the crop water requirement. So if you can perform both this analysis, second is the time series analysis. Like at every stage of the crop, you take the satellite imagery and then perform it. So at one stage, you will come to know when there is a requirement by the water, then only you provide the irrigation. So normally what farmers are doing is even if there is no requirement by the crop or the soil, still they irrigate it. So this can help in managing the irrigation properly and this will also help the crop to grow well because roots will um, require some aeration also when there is no water. Continuously flooding will get into anaerobic condition and then they may not perform. So you can do one is index based analysis and second is series analysis.
question is, can geospatial data help in early detection of pest and disease?
Yes. See, uh, geospatial technology can help you in predicting the pest and diseases by doing some kind of a, we call it as analysis, like which climate is suitable for which kind of a pest. So if we are putting those rules that, okay, if you get such kind of a humidity in your field, if such is the range of temperature, if such is the range of your moisture, humidity, temperature, or rainfall, and then this kind of a pest infestation is expected. So if you are getting such kind of a thing, then be prepared, do the advanced application of fertilizer. And it will tell about well in advance and how much to be done based on the area of your farm, the stage of the crop, age of the crop, health of the crop, what kind of application has to be done. Yes, this can be done. Pest prediction and the pest protection advisory.
Hello?
Yeah, yeah, yes.
Yeah. You could listen to the question.
Yeah, the
Uh,
last one I couldn't listen. The
how
first one I
how
have
ac-
answered it. Then after that,
how accurate are weather and soil moisture forecast using these tools?
okay. See, accuracy depends upon the resolution of the satellite image. If I'm doing a plot level study, and if I take a very high resolution satellite imagery, which is sub-meter pixel, that means even a half a meter of information I can obtain from the ground, then the accuracy is very high. It goes beyond 95, 96, 97 percentage. Okay. And if I'm doing a regional level study where the resolution of image is 10 meters, 20 meters, that means the minimum mappable unit of the ground is 10 meters. Anything below 10 meters cannot be captured. Then the accuracy reduces to 85, 80, 85 percentage. And if I'm going up to a national level study or a global study, then the accuracy reduces further and it will be around 75, 80% accuracy. So it depends upon what study you are doing and what kind of a satellite imagery you are using it. If I'm using a high resolution, means very low resolution image for a plot level study, my accuracy will be very bad. So I have to use a high resolution image for a plot level study. Then accuracy will improve.
Okay. And what mobile apps or platforms are available for farm level decision making?
There are multiple mobile apps and apps are available from the government of department. Also, there are apps available. We can Google it and find out from the private companies. Also, Plantix is one app which is for the disease prediction. Uh, our company, we do the database analysis platform, which is the Crop Intellix. That is for the crop data and database analytics. That is mainly for the carbon, your carbon calculation in your field. Then we have individual apps from the government departments for the pulses, for the paddy, Krishify, Agrify. These kind of some of the apps are there. So different purpose, different apps are available. So if anybody is interested, they can know, they can tell us what purpose they want to use it. Then we can find out who are the players they are providing such kind of applications.
Okay. And how how can FPOs use geospatial spatial technology for area mapping and aggregation?
Okay. So this is the basic work that normally we do. That is the first is the area mapping. That means Uh, the satellite imagery has to be taken. Then each and every feature on the ground will have a different reflective properties. So mm, a crop will be having a different reflective signature. Water body will have a different signature. Your fallow land will have a different signatures. Forest will have a different signatures. So we use some kind of a satellite image interpretation technique like tone, texture, color, pattern, shadow, association kind of a thing. And then we first take out which, for example, if I'm doing a paddy mapping, then which are the signatures that are for the paddy. Then remaining, I remove it. So only the paddy signatures will be available. Then we map it. Once the mapping is done, that means only paddy is now available with me. Next step will be I will take the administrative boundary. If I'm doing a study, let's say for Telangana, so I'll put a Telangana boundary onto it and flip it. So only the paddy inside Telangana will be available. Rest everything will be cut off. Now, third step will be the size of the pixel and multiplied by number of the pixels, because each pixel will be, let's say, 10 meter by 10 meter, and you will be having somewhere around millions of pixels will be there. So that size of the pixels multiplied by number of pixels will give you the area in square meters. So then square meters you divide it by 10,000, then you will get it in hectares. This is how the area mapping is done.
Okay. Yeah. What are the government programs supporting digital and precision agriculture?
Now all the government programs are supporting digital agriculture. Every program, even in your Fasal Bima Yojana, they have clearly mentioned now that it has to be done using remote sensing and GIS technique, no field work. Then your Sinchai Yojana, that has to be done through remote sensing and GIS. Then your Fasal program, which is the crop acreage program, again, satellite-based technology has been suggested to do, and now they're using it for last 7, 8 years for the crop area estimation, production estimation. Then what else? Sinchai Yojana, Fasal Bima Yojana, your crop acreage estimation, even your market one, the the mandi arrivals and all. These are also they are being done using satellite imagery. The other like non-government programs where the government is funding the wasteland development programs, livelihood improvement programs, they are also using this one. A non-profit organization, non-governmental organizations are also using it in their livelihood development programs. So most of the programs now they are using it. Um, Even they have started their own GIS facilities in each and every department.
Okay. So, last question. What skills or training do farmers need to adopt geospatial technologies effectively?
Okay, if it is for the farmers, they only need to uh, take the training on how to read the maps and how to interpret the output. If it is a farmer, but if is the next level like agriculture officer or agriculture student, or then they have to go for a different training how to uh, use the indices or how to run the models. That one. If it is the next level, like if you are in some kind of a input company, or if you are in insurance company, or if you are in education organization, then you have to do a different kind of a training of uh, the complete remote sensing and GIS, how to obtain the satellite imagery, how to process the satellite imagery, how to run the models, how to create the models, then how to generate the reports. So that kind of training is required. So it is for the different type of trainees, different trainings are required. For farmers, we suggest that they should only learn how to interpret the map, how to read the map, how to read the report.
Okay. Okay, Mr. Dinesh. So now we have come to end of question round. On behalf of agricultureinformation.com, we'd like to thank you for a very detailed presentation and answering all the questions in depth. So we'll be ending this meeting now.
Thank you. Thank you so
Yeah,
much.
you're most welcome. Thank you.